Wood joinery. We have covered a little bit about what's going on. So what I'm going to do is I'm going to do a quick intro. I'm going to cover what I'm looking for in the 5 wood joints you're going to build in the next 2 weeks. Once I am done with that, we're going to go over measuring a board. So you're actually going to go measure a board. You're going to cut a board today, all right? And then we're going to start weaning our way into the project. So again, hand tool work will happen today. So just to refer, from the top of your middle finger to your elbow, there is nothing. Glasses on your face at all times. All right, again, I'm not trying to protect the top of your forehead. I'm trying to protect your eyes. All right, if you have baggy sleeves, roll up the sleeves. All right. So with that said, let's get into wood joinery. All right. I always like using this video because again, it introduces woodworking in a very simple way. So again, we're going to go over why is it important to have mechanical joints to put woods at the magic number, which is 90 degrees. So, let's get into it.
What you'll notice when you look at houses and furniture and how things get built is that 90 degrees is sort of a magic angle. A lot of the tools and the machines around the shop are set up to deliver and guarantee that angle. Even in this workbench here, you'll see that the legs come up straight and the top is horizontal, and you end up with a 90-degree angle. The problem with joining pieces at 90 degrees is oftentimes you're trying to spread glue along the end grain of a board and get it to join to another board. That doesn't hold very well. So one of the simplest ways to reinforce that joint is to add screws to it. That's not the prettiest joint in the world, and the next step a lot of people do is with a special tool called a biscuit slider. And they slide in these biscuits. The advantage there is that the joint's very easy to cut and that it's invisible from the outside once it's glued together. Another very common and simple joint are these square notches in wood. This one is called a radome. It's used to add a little bit more surface for the glue to hold on to. That also can be reinforced with screws or biscuits. Another variation of that is a dado, which goes across the grain. We see these a lot in bookshelves. And the last variation of this joint is called a groove, and the only difference is it runs with the grain. This is how drawer bottoms are put in and cabinet backs. See these joints a lot, very simple, easy to cut. There are other joints you can make cut with specialized router bits. This one, called a Copen stick joint, was cut with 2 matching router bits. When you add a plywood panel to it, you get a nice frame and panel door with a molded inside edge, all from those same 2 router bits.
These basic joints are a great place to start. But Asa, why don't you tell us a little bit about joinery techniques?
Well, eventually you're going to want to build things that will even last longer than you will. And that's where the traditional woodworking joints come in. The great thing about them, the dovetail and the mortise and tenon, is that they're not only beautiful, but they're also bomb-proof. The most common kind of dovetail joint is a through dovetail. It's called a through dovetail because both the pins and the tails go through the other workpiece. If we take this apart, we can see some of the advantages to this joint. Well, you see from how hard it is to pull it apart that it's a locking joint. It's a mechanical joint. You don't even really need glue to get this joint to hold, but there's plenty of surfaces for the glue to hold on to. Another common and very beautiful variation of the dovetail joint is the half-blind dovetail. It's called half-blind because it doesn't show on one side. This comes in very handy for making drawers like this one here, where you don't want the tails to pop through and show. Another nice feature here is that you can use contrasting woods, one for the drawer side and one for the drawer front, to really highlight the beauty of the joinery. The other big star is the mortise and tenon joint. This table demonstrates 3 great variations. The simplest one is this here. This is a blind mortise and tenon in that it doesn't show on any of the other surfaces. But when you add glue to this tenon and it fits into this perfectly sized mortise, you end up with another bomb-proof joint. A nice variation of the mortise and tenon is when you send the tenon all the way through the workpiece and it comes out on the other side. It can create a beautiful decorative joint like this one we see here. And the last variation we want to show you is when the tenon comes out even farther, you cut a small notch and a wedge can go in. These kind of exposed joints are characteristic of arts and crafts style furniture, which is what this table is.
There are a few other things to consider when building furniture. For example, wood shrinks and expands when seasons change, and you need to take that into account when you're designing and constructing furniture.
So I like that because there's a good introduction into the majority of the construction joints we're going to use in this class. So everything that was covered in that video, minus the through mortise and tenons, you will build in some of the projects in this class. So in the beginning, for your project, so this is the step stool, just to give you an idea, right? We got dados, we got rabbets, we got biscuit joints, right? Those are three that were just mentioned in the video itself. So again, you will be using all the joints we covered to engineer your project to be the strongest possible part possible. Does that make sense? Right? So just covering types just briefly. There are thousands of types and variations of wood joints in the world, not including Eastern wood joinery. Right? So again, there are different geometric shapes that we can use to best take advantage of wood itself to make it a stronger structure. This is just a quick example I like to show because again, there's a lot of variations out there that we do use for both aesthetic and structural purposes. All right, just a few more common ones. All right, this is my little plug for Japanese wood joinery. We do not cover Japanese wood joinery, but it is worth mentioning because out of all the wood joinery in the world, they are the most aesthetic looking, the most meticulous, and the most structural. So,
I only know 2 of those 3 words.
what?
I only know 2 of those 3 words. I only know 2 of the 3 words that you said. What do you know 2?
What, Japanese wood joinery?
Yeah, but like, no. So you said like, you listed 3 things like
Meticulous, accurate, and they're really strong. Right? So just an example right here. Their belief is no nails, no screws, no glue.
That's cool.
For their houses, for their furniture, and anything that is built of wood. So everything that they design and build is held solely by a mechanical joint.
That's cool.
Right? So again, I like pointing this one out here, because again, they hand cut these. They sit there and they cut them by hand to perfectly fit each other. Right? And what's nice about it is when it ages, it'll expand into itself and lock itself into a permanent joint. So it will never come apart, ever.
That's cool.
That includes earthquakes. So again, the reason why they are so meticulous is again, over time they found that by doing this extra step, their structures last longer and they're more durable than any other wood design. Right? Again, I plug that because again, besides Western furniture construction, which we're going to primarily do in this class, I'm just focusing on letting you know that there is another level above what we do here. So we're going to cover to the highest level of Western construction, but again, Eastern construction goes even higher in skill level. So again, if you get the highest mastery level here in our woodworking program, that's the base level for Japanese woodworking. So again, there are very, very high standards for woodworking. Just want to let you know that. So, what do you guys do? So, I have 6 up here because these are the 6 primary ones you'll run into the classroom. You'll be doing 5 of them, right? So starting with the butt joint. What the butt joint is when 2 pieces of wood are basically end grain to base grain or edge grain, end grain to edge grain, is put together at a 90-degree angle, right? The only thing that's holding your wood joint together is a single nail and a little bit of glue. Now, when it comes to grading, what I am looking for is, if I take a square, is your joint at 90 degrees on the inside? Is it 90 degrees on the outside? Also, I'm going to use this term now because I'm going to drive it home. When 2 surfaces are in perfect level, we call that flush, right? So if I run my finger from one piece to the other, I should not be able to distinguish a difference. So that includes the end and both sides. Right? If there's a large difference, you're going to have to fix them. Does that make sense? Second, contact. So if I'm looking at the joint here, I hold it up to the light, and I can clearly see through your wood joint. That's not a good wood joint, and you'll get a poor grade. Now I'm going to plug this now. Can you go back and fix any wood joint we do in this class? Yes. Right? In some instances, I will give you an upfront grade and say, so this is what you're going to get for this project. You can accept it, or you can tear that part apart and rebuild it for a higher grade. So again, in this part of the class, This is where there's going to be a lot of failure. There's going to be a lot of learning, right? With that said, again, don't be afraid to restart and do it again. Because again, most of you will not get it right the first time. Does that make sense? So again, butt joint. Rabbit joint. Same principles. Is it at 90 degrees? Are there gaps? All right? Now, the key thing here is this one is not at 90 degrees, and I keep it just to show. Does everyone see that gap? Barbosa. You see the gap? Right? Main reason why this is not straight is when they cut this, they did not cut it at 90 degrees to the face. Right? So when we are carving out these wood joints, you need to pay attention to how you're cutting that piece of wood. All right? Does that make sense? So a rabbet will always be defined as a notch cut at the end grain of one piece to receive a second piece like this. Does that make sense? So that's how we hold it together. Primary spots you'll find that are on your project. They are responsible for holding the structural members in the back of your project. They're also used in drawers and the tops of bookshelves. They're very handy. They are weak in one spot. Because there is nothing on the top here to hold it in, if I apply a force here, it will break. But again, this is way stronger than a butt joint. Next, dado. So the first two joints, butt and rabbet, are the only two joints that will receive glue. Dado is purely a mechanical joint, so there is no glue at all with this joint. So when I am looking at this joint here, I'm looking for, obviously, clearance, so there should be no space. It should be 90 degrees, 90 degrees. And my favorite test. Let's just went back together. I'm going to take your piece and turn it upside down. If it falls out, it's obviously too loose and you need to start again. All right, so again, take your time when you're doing these parts because it's very easy to overcut something or overdo it. So again, the dado. From there, you'll do the cross lap. Right? We're going up in strength now. So dado is a lot stronger than a rabbet. Cross lap is double in strength than a dado. Because again, all it is a mechanical joint of two dados, so two dados combined together to create a piece that goes at a cross shape. Now again, what I'm looking for here, mechanical fit. If it falls out, poor grade. Also has to be flush. So if I run my finger from one board to the other, there should be no gaps. Does that make sense? All right? Final, mortise and tenon. Another mechanical joint. So on a mortise and tenon, the mortise is the square shape in the block. The tenon is the square pin here. So variations I have seen of mortise and tenons. I have seen triangle, hexagon, octagon, circle. Those are all still mortise and tenons, but as long as the hole that is receiving is the same shape as the tenon, it will go together and it's a very strong joint. Does that make sense to everyone? All right. Those are the 5 you'll be responsible for. I covered dovetails just briefly because in the higher levels, it is one of the strongest joints in Western woodworking that we will cover in 40 and 50. All right? Reason why it's the most strong is because it has a trapezoid shape. So again, they were talking about surface area and gluing. So in a dovetail, you have tails and you have pins. The pins, the surface area, is double or quadruple what a mortise and tenon is. So gluing surface area is high. Also, because of the trapezoid shape, it locks together, so it does not allow you to take it out unless you take it out directly out of the shape. So I can put a force downward, sideways, I can try to rack it out, it won't move. What? Kinda, I'm just gonna cover it just real quick, right? But that is it. So, we're gonna practice a listening game, right? You're going to break into pairs. You're going to be wearing safety glasses. In the woodroom, up on the top right-hand side, there are 2x4s. Each pair will grab one 2x4. You'll take a square, combination square, or tape measure. You're going to measure out 6 inches, mark on one end for one partner, and the opposite for another partner. So, let's get started. Okay.